Hi, this is Dave Vernier, and I want to introduce you to our new projectile launcher. Basically, it's a system to launch steel ball bearings in a very reproducible way using air pressure. The system comes with some wax tape, which you can lay down on the table, and you'll get a mark every time the ball hits it. Today, just before this video shoot, I shot onto this tape about range 1.5 meters, and you see I got a cluster of 5 hits pretty close together. Let's take a look at how the thing works. Basically, you've got a control here, which is a limit valve on the pressure. So you pump up pressure, but the pressure will at some point start bleeding off so that you get a set pressure controlled by that knob. You can control the launch angle right here. And the neat thing about this design is that no matter how you change the angle, the launch point is always right there. 14.6 centimeters above the table. It doesn't move horizontally or vertically as I rotate this, which makes some experiments easier. The system does require power. You can either get power from a LabQuest power supply, which you connect right there, or the better option is to connect the projectile launcher to one of our interfaces. Here I'm using a LabQuest 2. You could use an original LabQuest, you could use a LabQuest Mini, or you could use a Lab Pro. That both supplies the power needed, but more importantly, it connects you to the 2 built-in photo gates, which are right here and here. They're 5 centimeters apart, and they're right at the point where the ball comes out. So with these photo gates, you can measure the speed of the ball very accurately right at launch time. And that opens the door to all kinds of interesting experiments. For example, you can have the students launch the ball into their hand, measure the speed, and then they have to calculate where the ball will hit and put the target at the spot. Here we have a little cup that we're going to try to hit later. If you want to make that math easier, you can raise the cup up, the target up, so that it's the same height as our launcher, and then that makes that calculation very simple. If you want to make it tougher, you don't do that, and then the students have to allow for the height change. That's a better calculation for advanced students. So let's try a launch. First, I'm going to put on my safety glasses, 2 pair included. Now I'm going to pump up pressure. And as I pump until I hear the chirping sound, which means pressure is bleeding off. We're at the limit. Now I want to start data collection on my interface because I do want to get the speed. And one more safety feature is to launch the ball, I have to both hold the arm button and the fire button at the same time. And let's give it a shot. We hit the target, and you might have seen some lintel beams fly out of it. We put those in to absorb the impact so it doesn't bounce out. We should look here. We did measure the time. We got 4.047 meters per second for the launch speed. We think your students will have a lot of fun with this system. Please refer to our website if you have questions.